Hello everyone. Today we are going to discuss a very interesting vulnerability that is XXE and specifically blind XXE. XXE also stand for XML external entity injection, where we deliberately exploit how server parses an XML that is being sent from browser to the server. When we talk about blind XXE, we also say it as the out of band XXE, and that comes under the category of out of band injection because in return we are not able to see anything in response. Instead, we use a external server. In this case, we load a external DTD from our control server, or a hacker will load an external document type definition from an hacker controlled server. So basically, a document type definition in a nutshell explains the syntax of the XML and entities that is being defined and declared. So if we see here, we have a document type tag with the root element, and inside that there is a declaration of entity. So when we discuss on a topic of out of band or blind XXE, we generally focus on the parameter entities, where the parameter entities are declared using the percent sign. As we can see, percent sign and a space followed by the entity name. So here a parameter entity is being declared or using a preserved or a predefined keyword system. We generally call or make an entity to relate, resolve, or link whatever protocol that we provide. In this case, we are using HTTPS. We can use FTP and other protocol as well. So the entity is being declared, and when we have to call or call the entity, parameterized entity, we call it in a way that there will be a percent sign, the name of the entity followed by semicolon. So we can see that we are calling a parameter entity, and that is already declared and defined. This entity is going to make a request to hackerserver.com where a malicious DTD is hosted, right? But what about this? These are two different entities, that is parameter entities, that is being called. But where is the definition? So when we see that the malicious DTD that is being hosted on a hacker controlled server, it contains the DTD contains this two entities, where in the initial entity there is also a parameter entity name file, and that is fetching the data of the file /etc/hostname. Post that, what we see is there is another entity that is URL, and we also see that inside this entity one more entity is also defined, that is resolve. I mean, I have abbreviated it as RSLV, so we are referring it as resolve. Okay, so there is also a entity resolve, and it's making request to malicious DTD, and we can see that the initial file entity is being called. So what actually is happening? This is dynamically generated entity which is called whenever the URL entity is being called. Okay, post that we see that it is HTML encoded format of percent sign itself, and this is deliberately done because in this case what we consider is the encoded data must be considered as a part of an entity, not thinking it as a special character or reserved character that is already reserved for the XML language. So what actually is going to happen is this encoded data will be sent to the server. The server will accept it as a part of the entity. Later on, it will get parsed by the XML parser. That could be using any API or any specific parser. Okay. At that time, this encoded data will be decoded into the format of percent, and entity percent resolve will work as a normal entity. So to demonstrate this, I'll be using the Portsugar Academy labs to see the functionality, like how an external DTD is being called, how it is being used, and we'll see a step by step that how actually the XML parser parse it, and how the entities are being referenced one by one. So I'll be using the lab where it is mentioned that we are going to exploit the blind XSE to exfiltrate data using a malicious external DTD. And this lab has a check stock feature that parses XML input but does not display the result. Of course, since it's a blind one, we are not going to see the result. So to solve the lab, we need to exfiltrate the content of the file /etc/hostname file. Fine. So we'll access the lab. So when we hit the request to check the product stock, we get the stock quantity to be 98 as same as in the UI. Fine. So from this, what we know that we are going to declare a doc type, because to make a XML request, we need to define a doc type, and we need to define an entity that is a parameterized one entity. So let's start, and we are going to start with writing a doc type. So the doc type will be named foo, and we are going to make an entity call as well, and the entity will be a parameterized one, so we'll be using the percent sign, and this sign will be the name of the entity will be x. Suppose that what we want to do is that we want to hit a request to an external malicious server DTD. So sorry, this will be system, and in a double quote we'll be passing the URL. So for this lab we have an exploit server. So the exploit server is saying that we are having a file that is named as /exploit. So this would be our malicious DTD. Okay, so in the front end maybe it's not showing as exploit.dtd, but intentionally uh, it is a DTD file that is being loaded. Okay, and whatever the internal data of this external DTD, we are going to write here as well, the payload. So right now the main motto is to hit a request to this external or the hacker controlled server, right? So it is going to hit request. The another important thing is that whenever we declare and define a parameterized entity, we have to call it inside the doc type itself. So after this angular bracket, we need to call the entity, and we have to close it using this semicolon. That's the required syntax. And I believe if we are solving a blind one, then we are already aware of how and what actually are entities, how they work. So for now, that's it required. Now let's come to the malicious server where we are having our DTD file. So in the lab, it is being said that we need to retrieve the data of the host name. So in this case, we have to declare more entities. So initially what we can do is we need to get the data of /etc/host name. For that, we are going to define one more entity, and we can name it as file, since we are going to retrieve it file, and we are going to make a request that will be using the file protocol to call the internal system files. and that will be slash etc slash host name. Okay, so till now this parameterized file will get or fetch the content of slash etc slash host name. Okay, fine. Then once we get this, how we can fetch it, how this application uh, will include this external DTD, and the XML parser of the vulnerable server will parse it. So for that, we need to hit a request, right? So again, we are going to make one more entity, and this time I'll name it as URL, and inside this, we are going to define a dynamic entity. So what I mean by that is, once this entity is being called, a new entity can be replaced by that parameterized entity. So what I mean is, there will be a new entity, and we can define it and declare it with resolve, and we are going to make a system call for a URL that is the malicious URL, right? And when there will be a request, when the malicious server will get a request on a specific endpoint, it will log it, right? So what we are going to do is we'll log the content of slash etc slash host name as well, and we'll see if the XML parser parses it well. So we will call it, right, and we can close the internal entity, that is the dynamic one, and that is our definition of the entity URL. We can close this one as well. So what we have done is we have defined and declared the file entity. Post that, we have defined the URL entity, which is containing a dynamic entity, that is resolve, which is making a request to the malicious server and containing the content of the etc hostname file in its request, right? So let's store it. It's taking more time than usual. I guess there is a issue with session. Let's copy what we have written so far, and let me close it, reload the application. We are going to go to the exploit server. Let's see if the exploit server URL doesn't get changed, and if it will get changed, we'll replace it with the latest URL that we have. And from the previous repeater tab, what we are going to do is just simply copy the doc type that we have declared and the definition of the entity that we have written. Check. Okay, we have the payload itself here, so there is no repetitive task. So we already have a stored one. What we are going to do is we are going to hit a request to the server, and let's see how the server behaves while receiving XML payload. So what we see is XML parsing error. Okay, fine. So how to know that whether it got initiated or the server is making request to the external domain? For this case, we are having log as well, and we can check whether we got any received any request any logs here. And let's send one more time a request and reload the tab. We see that yes, we are getting HTTP request to the specific endpoint. That means the blind XXE is happening and we can exploit it. Fine. So the initial part is done. Now, why we were not able to get the host name here? Since we are sending the data of the /etc host name into this entity, why even after hitting a request to this specific endpoint and adding a hyphen with the host name is not making a request, it's not making a successful request to this, and why it is not getting logged? So initially, to summarize it, how actually it is happening, let me explain it step by step. So when we declared this doc type and define this entity and call this entity, so in the very initial step, what actually happens is it will make a request to the external malicious servers DTD. That is the external DTD. So the HTTP request and the loading of the external DTD is being done using the entity X. So the doc type that you see here and the definition into the square bracket gets changed or replaced by the value of the external DTD. Whatever is defined into the external DTD will get replaced. So you see the all the data in the yellow part till the yellow angular bracket get replaced by the modulo X, the percent X, that is an entity, and still URL and resolved entity is there. So in the initial step, this happened. Then in the second step, when it will get parsed by the XML, we see that after the calling of X entity, we have a call for URL entity, right? So the definition of the URL entity, we can see that it is having a dynamic entity that is being called. The data of the URL will get replaced by this entity, which is named as resolve. So in the second step, the value of the URL entity will get replaced by the new entity dynamically, and in this the value of the file entity will get replaced by the actual content. So whatever will be the host name of the machine, it will get replaced. So whatever the name will be there, it will be appended here. Now in the last step, we see that there is a call for another last entity, that is resolve, and this resolve entity is going to hit a request, HTTPS request, to the malicious server exploit DTD with the name of the machine, with the host name of the machine, and it will get logged. We also see that there is already encoded format of the percent sign, which declares that it is to be treated as a part of the entity rather than being treated as the special or reserved character of the XML, right? So what we see is the payload that we have created is missing the encoded uh, part, right? We are simply directly putting the percent sign, which is going to cause a internal parsing error, right? So here what we need to do is we need to uh, put the HTML encoded format of the percent sign. So we will encode it as HTML, we'll copy it and we'll paste it here, and we'll again store the payload. Let's go to repeater and let's again hit a request to this specific uh, external DTD, and we see that we didn't get the error, and we get something which is a valid data. Let's go to log and check what actually happened. So what we can see is still we are not able to hit the URL with the host name in it. So the reason is that even we have declared the file, but we haven't called it, and we are missing that calling of the entity. So we need to call the entity here, and the entity name is URL to so that it will dynamically call the entity resolve. And again, we are going to call the entity resolve, which is going to hit the request that we have defined here. That will include the host name of this machine or the vulnerable application server. Let's hit the request again. So again, what we see is it shows us the XML is being parsed, but there is some error. Fine. Now let's go to the exploit server and let's check if we are able to successfully hit a request with the host name appended with the hyphen sign, followed by the hyphen sign. Let's reload it. We are not able to get what we want. What could be a possible reason for that? So what I can see is we need to put a single quote, as we have started a single quote for this URL, but we haven't closed it. Let's see if we are able to hit it properly this time. And let's again hit a request. XML parsing error, and let's go to log. Let's check whether this time I'll be able to get something. Okay, great. So this time what we see is we were able to successfully hit request to this defined entity URL with the exact data of the file entity, the etc slash host name. So what we got is the host name, and let's copy it and let's submit the solution to solve this lab. And great, we have solved this lab, and it was a great discussion that how actually a blind XXE works.